Today we are going to code in essentially Gaussian elimination, and we're going to call it Gauss Naive because there are going to be some points in the code where we could end up with division by 0, which would be problematic. Okay, but we will fix that in another function here later on, not today, but next week. And before we start, I just want to kind of build in maybe one error message, and then we're going to look at an example before we actually start really getting into coding here. So the first thing I would say is, for simplicity, we are going to look at square matrices. Which means if m is not equal to n, error matrix A must be square. Okay. And it's not because Gaussian elimination doesn't work for systems where A is not a square matrix. This is just for the sake of simplicity. Okay. All right, and so next we're going to want an end. Okay. All right, and now let's go and look at what we have going on here. Okay. So here's a 4x4 matrix A, okay, and here's the vector B. Okay, and so it's just been augmented. And I want you to notice a few things. So I've actually done 3 row operations here in this first step. But what's happening in this first step is we're using the first pivot, and I want to point out what the pivots really are. They're these things. Okay? And what we're going to do with these pivots, and sometimes you'd count this one here too, but we're not going to use the last one, and I'll explain why. What we do with these pivots, if I can not erase what I want to erase, there we go, is say with this 3 right here, we're going to eliminate everything below it using it. Okay? You can see all of these are dependent on row 1, and so we're using row 1 every time to get rid of what's below row 1 in column 1. Okay, and let me maybe highlight in a different color so you can see we have zeros now below that 3. Okay. And the other thing I want you to notice, okay, is how we get these factors. Okay, so the factors are the things that I'm putting in front of R1. Okay. So every time we're subtracting the row that we want to change. Okay. Or let me reword that. Let's say we want to change row 3. We're doing row 3 minus some multiple of R1. That's what we did all 3 times here. Okay. And to get that multiple or factor is what we're doing. Let's maybe consider this first one. Is we're taking the pivot and putting it in the denominator, and then the number that we're trying to turn into a 0, we're just putting on top here. Okay. And so that's what we did for all 3 of these. Okay. All right, and you can see there were 3 things to eliminate below the 3, right? Well, when we get to our next pivot, there will only be 2 things to eliminate. And in fact, we're lucky there's only 1, but technically there will oftentimes be 2 things to get rid of. Okay. All right. And then this would be looking at the second pivot here. We would be using this 5 to eliminate the 2 numbers that we had below it. Okay. And then for our final pivot, okay, which happened to be a 1, there was only one thing to get rid of below it, but it was actually already 0, so it didn't matter. Okay. But I still did the calculation just so we could see it. So first pivot requires us to do 3 different row operations. The second pivot required 2, and the last one required 1. And then once we did that, we are in a form now to where we can perform back substitution. Okay. So do note, we only had to go through 3 pivots, and A was a 4x4. So it was, we were really doing 1 less than the number of columns in A, or the number of rows, whatever way you want to think about it. Okay. All right. Well, let's go over and see if we can start coding this. Okay. So I'm going to add in something here that's not going to make sense yet, but I'll explain what it is. Okay. So I'm going to call this NB, and I'm going to say it's n plus 1. Okay. So this number here is just accounting for the fact that when we augment A and B, the resulting augmented matrix is going to have 1 more column than A would have, right? Because we added a column to it. We added B to it. So that's all that that's accounting for. And let's also create that augmented matrix. Okay. This augmented matrix is what we're going to be performing our row operations on. Okay. Maybe I'll put this in here. Number of columns in aug, which is right here. Okay. A augmented with B. Okay. All right, next on our list, we are going to start the row operations. Okay. And so we are going to note this in here as forward elimination. All right, and we're going to go ahead and we're going to start our for loop. Okay, and I think I used I on the previous page when we were in OneNote, but I'm going to use K here. So these K's here are our pivots. Okay, so remember we started with pivot 1, moved on to pivot 2, and then pivot 3, and then we didn't mess with pivot 4. We stopped 1 short of really the dimension of A, if you're just thinking about its columns. Okay. So I'm going to say 1 to not n, but n minus 1. Okay. I'm going to put that comment there too. Maybe that'll help us out a little bit. And now I want to point out what we do once we're on a pivot. Okay. And so I might actually change the letters I used here, though. I used something I don't like. Let's make this K. There we go. Okay, so this is for K equals 1. This would be K equals 2. And the last one would be K equals 3. There we go. So the K's are telling us what pivot we're on, but then notice we have to mess with the 3 rows below the pivot. Okay. So we'll be running what, for I equals, and we're really actually starting to mess with 1 row below the pivot. So maybe you could say K plus 1. Let me write that. K plus 1. So 1 more than the pivot. And where do we want to end at? Well, we want to end at row N. Okay. So this is going to be reflected in our code here. We're going to need a separate for loop that'll calculate all these and all these factors. Okay. And that's not what I'm looking for. This is what I'm looking for right here. Okay. So we have 4, K equals 1 to n minus 1, and then we're going to have 4 I equals, and we said we were going to do what? K plus 1. Okay. And we were going to go to n. Okay. Go down to the last row. And so maybe here I'll denote this as rows. I think there might be some times where we might use this to describe a column, but we'll see. Maybe we'll just use that for now. Okay. All right, and then next we want to compute the factors. Oop. So if you remember, in the factors, we were always dividing by the pivot. So og of, and so keep in mind here right now, what pivot are we on? Okay, what pivot are we on? And remember, these pivots are being counted by k, so we're on pivot k. So I'm going to have k, comma, k, because the pivots happen along the diagonals. Okay. And then the question is, well, what's going to go up here? Okay. Well, what we'd like is we'd like to be in the column that is k, where the pivot is. Okay. But we want to use the rows below it, so we would be using row I. Okay. So that's how we're going to compute our factor. Okay. And then the next thing is we want to build in our row operation. Okay. So we would like to essentially edit row I. We want to change row I, okay, and we want to change it. Okay, I'm not going to put everything in here yet. Okay, just pretend right now that we're just saying row I equals row I minus factor times og or row k. So again, we're doing row I minus some multiple of row k. We're essentially doing these little operations right here. Except for we need to be a little bit more specific. Okay. So when we do this, we again are doing this on the entire row. Okay, the entire row. And I'm going to come back and change what I'm saying a little bit in a minute, but I think this will be a good start, just noting the entire row. Okay. Let me open this. There we go. All right, so if we're looking for the entire row, how would that look? Well, we said that we were in row I, and what that would mean is we'd like every column of row I, right? And now we can actually do something a little bit clever here, okay? And let me explain what we can do that's clever here, if I can click the right tab, okay? So note, when you move down to k equals 2, right, we don't have to do any subtraction in column 1 here anymore because it's all zeros, okay? And once we finish up pivot 2 and move on to pivot 3, we don't have to do any subtraction in column 2. So every time we move over a pivot, we have one less column that we actually have to worry about, or one less column that we need to do operations in. Okay. So let's see if we can adjust that. We would like to go, let's consider this case for k equals 2. When k equals 2, again, we did actually want to get rid of the things below it. Okay. And we did. That's why these are highlighted as zeros. And we'd like to still be making these operations on the remaining elements in these rows. Okay. And note, there's more than 4 here. There's 4 plus 1 elements in each row. That's the NB we were talking about. So we're going to go from K to NB. Okay. Again, this would be column K, this would be column NB. So we're going to go, instead of doing the entire row, we're just going to go K to NB. So let's see what that looks like now. Okay. So next, I want to put that in here. So we wanted to do row I, but we don't need to do the whole thing. We just need to go from column K to NB. And same with here, column K to column NB. And we'll do that for our last one here as well. K to NB. All right, and I'm going to go ahead and suppress that. Let me make sure I suppressed everything else. Okay, yeah, everything else is suppressed. That looks good. All right, we'll end this. So that ends the first for loop. We'll end the second one. And this is going to get this into a form to where we can use back substitution. So we'll actually want to go a little bit further with this. We want to do that back sub. All right, and so the first thing that we're going to do is we're going to be creating our vector kind of backward. So we won't be putting in the first element and then the second element and the third. We're going to go from, in our case, if we're looking at the system that we had in OneNote, we'd be doing x4 first, and then x3, and then x2, and then x1. And just so you can see it, I should just pull it up here. Right, the first thing we calculated here was x4, okay? And it was because that's the first element that we can see what it's equal to. Okay. So let's go make one quick adjustment in MATLAB here. So is what we're going to do so that MATLAB can handle the fact that we're filling our vector backward is we're just going to create a vector of zeros to begin with, and then we'll fill it in with the appropriate values with a for loop here, okay, using our back substitution. Okay. But this is just saying, hey, we have a vector that's n by 1, okay, n rows, 1 column, as expected. Okay. And now the first thing that we're going to put in there is the nth element, or again, if we're thinking about our case that we had in OneNote, the fourth element. Okay. And let's think about how you calculate that. Let's see here. Here's my OneNote. To calculate that, do keep in mind we have a coefficient of 1 here times x4 is equal to 1. So to get x4, you technically want to divide the 1 over here by the coefficient of x4. Okay. So this is really, to find x4, you're really doing, if we look right here, okay, we would want to do what aug of, so this element here, this is in row n, column NB, okay, and we'd like to divide that by the element that's in space n comma n, or 4 comma 4. Okay. So this would be 4 comma 5 and 4 comma 4. So that's what we're going to write on the next page. So we have x of n, our nth element, is equal to aug of n comma nb divided by aug of n comma n. Okay. And now we're going to need a for loop to fill in the rest of these. And one thing that is kind of neat about our for loops in here is they don't always have to go in increasing order. We could say from n minus 1, let me fix that, for I equals n minus 1 to 1. So getting the rest of those elements in reverse order. we are going to compute x of I. Okay. And we're going to do this in kind of a clever way, so I'm going to have us actually go back and look at one note. If I can get my screen to unfreeze here. Oh, that's the issue. Okay, here we go. So now we're going to switch back to one note. Okay. So in all of these, let's see if we can kind of think about them in a different way. And I'm actually going to start off with this one. Let's see if we can find this 45 here, or minus 45. Okay. That's this top row here, right? Okay. So if we were to write that, we might write that as og of, and we're in this case, row 1, and that is space NB, or column NB. And then we're going to subtract quite a few things, right? We're going to subtract, oh, did I write that in the correct order? Minus 45. Let's see. Yeah, that's in the right spot. But even though it doesn't quite look like it, this was a minus negative 12, minus negative 6, and then, of course, a minus 9. So there were some negatives built in here. But the question is can you think of anything else that looks like the product of a bunch of things and then added together? Okay. And the answer is, yeah, there is something. There is something. It's called the dot product. So that's what we're going to utilize here, is the dot product to kind of simplify our code. Okay. So let's think about how we can maybe get the first numbers here, the 12, the 6, the 9. Where did those come from? So those came from these first, or not first three, the first row, elements 2, 3, and 4. Okay. So if I were to write that kind of using our same notation here, we'd have og of row 1, and then we'd be going from element 2 to element 4. Okay. Or we could say k plus 1. Maybe we'll do that in a minute. Maybe I'll do that actually right now. So we're on pivot k. All right. Although we're using a for loop that's starting at I. Maybe I'll just leave it for now. I'm not going to try to generalize this completely yet. So we'll go from, again, row 1, columns 2 to 4, and we wanted to dot those with something. Okay. And is what we're dotting it with, if you look at all these numbers next to these are precisely the x values. Okay, and let's see which x values. 140. Well, that was x4, x3, and x2. Okay. And we want to make sure that these go in a certain order, right? We would like to make sure that we're doing, for instance, this 12. See, this 12 here should be associated with x4. The 6 should be associated with x2. And the 9 should be associated with, the 9 should be associated with x2, this one x3, this one x4. Okay. So we will be using our x vector that we just created, but we're just not going to need everything in it. Okay. We're not going to need everything in it. Okay. What do we need in this? Okay. That is the question. So we would like to have everything up to n. Okay, so that's the fourth one, and is where we would like to start is at actually 2 here. Okay. So these are essentially saying the same thing, 2 to 4, 2 to n. Okay. So this is just a dot product that's going to give us, I'm going to undo this, it's going to give us this part here that I kind of have marked off in green. And then the last thing that we want to do with all this is you can see that this has been divided by the coefficient that was in front of x1. So this is divided by og of 1, 1. Okay. All right, and maybe let's go ahead and switch to MATLAB and see if we can get this in there. This is the idea. Okay, so we have x of I is equal to, and we have og, and then we have I. So right now we are working on I guess we could say equation I if we wanted to. We're working on solving for x sub I. So everything we're going to do is going to come from row I. Okay, so row I, column NB minus, okay, so this is just that first number. Okay. This is just that first number, the one that's on the augmented side. This is from column NB. Okay. And then here's the part that we were just talking about with the dot product. I'll just go ahead and write in the dot. So for this augmented part, we would like to be, again, in row I. Okay. And so we can, I'll just leave that like that for now, row I. And then the question is, which columns did we care about? Okay. Which columns did we care about? Let's maybe go back and look. So here, we cared about all of the columns. Maybe I'll go up actually even a little bit. We right now with this green part we have down here, we were calculating x1. Okay. And is what we cared about was we cared about all of these numbers to the right of the pivot. Okay. All the numbers to the right of the pivot. So that would really be, let's go down here. We're on pivot I. So how about I plus 1 is what we'll put in here. I plus 1. Okay. And then we're going to end this on the last entry of A, which should be N. Okay. And then which part of X do we care about? Okay. And it should be the same number of entries, the I plus 1th entry to the nth entry. And we could see that being true if we switch back to OneNote here again. Okay. So if we thought about what x values we actually used, we used 1, 4, and 0. So the one that we didn't use was 1. So we went from I plus 1, so 1 plus 1, to n, which is 4. All right, and let's see, are we missing anything else? Yes, we are. We also want to divide by the number that is the pivot. All right, and that actually ends it. And so I'd say, let's save this, and I'm going to suppress maybe a thing or two here. And let's also make sure that so our output should be X, and that is what we were searching for really this whole time. So our output here is defined. Okay. Let's go ahead and hit save. And why don't we try out that system that we have actually in OneNote? Okay. So I'm going to pause this so I can type it in there. All right, So I have it there on the side. So A was 3, 9, minus 6, minus 12, minus 2, minus 1, minus 6, 28. And I'll probably double check this after I type it all in. 2, 1, 7, minus 22, and minus 1, minus 3, 2, 5, and that looks good. Let's go ahead and make this look a little bit cleaner though. And then we need semicolons to separate our rows. Okay. And why don't we go ahead and suppress A, and we'll also need B. And B is minus 45, 10, 0, and 16. Okay, and now I'm going to double check what I've typed in here. It would be pretty easy to make a typo. Okay, and I think this is looking good. Okay. So next, we actually could solve this using the backslash command, and maybe we'll do that. We'll use both the function we created and maybe we'll also use that backslash command. So why don't we say x b, and this will just be using the backslash command, b for backslash, and how about a backslash b, so that we can see the output there, and hopefully x sub g for Gaussian elimination, hopefully this will give us the same thing. And Gauss Naive A comma B, and let's go ahead and run it. Let's see here. Let's give this a new name. Alright, and let's see what issue we got going on here. We might have some extra characters here in line 4. Oh, line 12. NB equals n plus 1. Alright, and I think I just found our typo here. I put A here and I wanted this to be OG. Okay, OG in line 18 there. I just input A. Let me see if I made that mistake anywhere else. Doesn't look like it. So let's go ahead and give this another try after saving it, and hopefully that does the trick. Alright, I have found what I think is the last error in here. So because of this unconventional for loop here counting down, we should be specifying that we are decreasing by 1 every time. Okay. So let's save one more time, and let's hope that this fixes the trick here, or fixes the problem. Alright, problem fixed. So I had a separate Gauss Naive file saved when I was just messing around with this, and it wasn't finished, and so there were some missing characters in it. And so if I go ahead and hit run now, we'll see that we get everything to work out. right? And you can see we actually get the same answers from the backslash as we do with the Gaussian elimination. Okay. All right, and that is it for today. Have a good weekend.